Hi, I'm Bill Stephenson with UiPath. I'm a strategic account executive, and this week on the Agentic Advantage, Masaki and I are going to unpack some exciting frameworks for you to leverage inside your company as you begin to build out agentic automation workflows.
Hi, my name is Masaki Kumamoto from the UiPath incubation team. Our team worked with global enterprise customers to identify those 12 different patterns. So I hope this is going to be interesting to you guys.
Masaki, it's exciting to be back with you for episode 5 of the Agentic Advantage. And I'm really excited about this week because we get to talk about specific frameworks that will give our listeners ideas for how to leverage agents in their workflows alongside robots, alongside humans to accomplish business processes more efficiently, more effectively, and with less cost. And I spent this entire week in front of customers. We had customer meetings, we had a summit for some of our customers, and I heard them say over and over, how do I deploy agents such that I get maximum value, but also have good governance and control? And then how do these agents work with my robots, my traditional robotic process automations? How do they work with tools that have access to databases, to other applications? So this topic is really in the forefront of customers' minds about how do we deploy these agents for maximum efficiency. And I know you have a pretty exciting framework, so I think the audience is going to get a lot of value out of hearing from you and how we deploy or how they deploy and what that looks like in a real world example.
Yeah, for sure. So our incubation team worked with global enterprise customers, and we started to see some common patterns. And we realized this common patterns enablement is really helpful for people to identify right scope of the agent use case and actually start to implement. And once you understand this common patterns, now you can start to see new opportunities every time you see automation use cases. I'm happy to introduce those 3 different categories, 12 different types of agent patterns today.
Yeah, I think it's going to be really helpful for our audience. So let's bring them up on screen now. The first one you're going to talk us through is really in this broader category of semantic data operation. Mm-hmm. So I can see there's 6 categories here. So maybe give the audience some, Masaki, like a flyover of how to read this, and then maybe double click into 1 or 2 to give us some more detail.
Yeah, for sure. So semantic data operation has a word semantic. It means the interpretation of text or data. Agents with large language model power is really good at understanding the data with the meaning of actual data, which robotic process automation was not really capable of. For example, if you get email or some item lines, you might be able to do deterministic if-else condition with RPA, but it didn't really understand the meaning of the data. But with agent, it can understand the data and do certain operation based on that. And those 6 patterns, 6 types of the agent operation is the common pattern that we started to see more and more.
Why, Masaki, are there 6? I know there's another 6, but why do these 6 fit inside of what we call semantic data operation?
Yeah, great question. So these operations are something, technically speaking, robotic process automation is already doing in certain extent. So, for example, classification, extraction, formatting, matching, searching, validation. There are things that RPA deterministic approach can be applied for those operations, but there are many cases where semantic understanding of data is required to do those operations. So other type of agentic common patterns such as natural language processing, reasoning, those are the things that only large language model can do. But this semantic data operation tend to sit in existing automation process, and you can apply agent for those process easily. And it tend to be higher transaction, so the ROI could be significant within this category.
It's interesting, you know, I mentioned I was at this customer summit this week, and one of my customers leaned over to me and he said, you know, we have all of this data. Some of it's sitting in data lakes, but there's other disparate data, and they need to pull this data together, and they need to build reporting out of this data that they share with executive management and others. So this idea of semantic data operation in these categories is really germane to how customers are thinking about leveraging data, reporting data, and ultimately acting on data. So maybe just to give the audience a flavor for how the agent works in these buckets, maybe double click on one or two of these and let's get a better idea of what's going on.
Yeah, for sure. Let's get into it. So the first example is a classification. I think I mentioned the use case of general ledger coding in the prior episodes. That falls into this category. So as everybody knows, classification is something when you get certain type of data or text, you classify those data into the predefined taxonomy. It could be label or type of data. So in general ledger coding example, general ledger codes are the list of taxonomy. Other use cases, harmonized tariff schedule classification use case. Harmonized tariff schedule are the list of the classification. And the other use case is something like email categorization. Depending on the content of the email, you might want to classify, or you could also say label certain email, or maybe routing the email. What's the purpose of this email? And usually company has predefined label for each purpose. So you classify the input data, email, text, something, into certain predefined taxonomy. And usually it sits in the earlier stage of automation process so this is going to work as a router of later part of the automation. And it happens to be the case that agent is really good at it.
What's interesting about this, and again, I'll refer back to the conversation I had with a customer just 2 days ago, is a lot of this work today is happening with humans, right? And as you look at this screen, you can see classification and extraction and formatting, matching, searching, validation. These are all extremely laborious activities that oftentimes, due to disparate data and different sources and different formats, has to be done with a human.
Yeah.
But now with agents, we're in a new world where the agent can handle a lot of this work and do it faster, more consistently, with fewer errors, and without getting tired.
Yeah, that's the most important part. And what's cool about agent is because it has autonomous tool users capability, if it doesn't have enough context to execute those operations, it has an ability to refer some of the information from internet or internal applications using UiPath automation to make the output of each operation more sophisticated or more accurate. That's exactly what humans are doing to do so. So
right.
It's really exciting to see some of the use cases.
In the customer example I was mentioning, this customer was indicating that, you know, after this process happens, what they want to see is this data go into some type of report or dashboard, and then that dashboard or report gets sent to the appropriate managers and executives on time so they can make business decisions in a way that's efficient, in a way that's cost effective, in a way that gives them a differentiation from their competitors. And really that sending of the data or the sending of the report, that's really where RPA or traditional robots would come in, correct?
Yeah, that's right. So once the classification happens, it's usually right after what's going to happen is make the robotic process automation to do some kind of a deterministic action into, in your example, email, sending email, or maybe creating tickets, or general ledger code example, it's inputting a classification information into the system. That's where you want to utilize robotic process automation, because you don't want the agent to access directly any enterprise applications and do ambiguous tasks. You wanted some uncertainty, certain action to happen in the application.
Yeah, that's such a good point. I know we mentioned it on a previous episode, but that idea of the agent and the traditional robot and the human in the loop all working together is such an important concept, because like you just said, I'll double click on it, is if you're going into a system of record to get data or upload data, you really want that activity done by a deterministic robot, right? That follows exact rules every single time.
That's right, exactly. And the other interesting example is searching, because that's something often enterprise automation required to do, like getting certain information in a kind of ambiguous way. Maybe the input is, some natural language came from email. Like, let's think of customer support example. You get the customer support inquiry, and we classify the type of query, and then now let's say it's a complaint about certain product, and the product has, the company usually have a knowledge base of what kind of complaint is sent and what kind of response was made previously. So you might want to search for those information from the knowledge base. And the searching type agents are good at building a query that can be sent to the system out of the natural language that was sent from the user. So agent will convert the natural language into the certain query format, and then send that to the system, and gain the system of records to the robotic process automation side, or agent, or whatever the calling entity.
It's interesting. This is bringing back memories, Masaki. As you know, I worked for Ford Motor Company back in the early 2000s, and right after that, I joined a software company. That was my first kind of technology job. And we were using scrapers to get publicly available information from the internet. It was peer-to-peer conversation. We were using natural language processing to filter through that context, those conversations, and pull out relevant information, like the type of product features, product complaints, that kind of thing. Then we had an industry level taxonomy that would run that data through. Then we would build dashboards and reports for customers. And I mean, if we had this process that we're showing on screen for that, it would have been so much faster. It would have been so much more comprehensive. And for us and our customers, it would have been so much more cost effective to do. Now, of course, back then we didn't have agents to rely on, but we're in somewhat of a new world, right? Where people can rethink old ways of doing things.
I 100% agree. It's really exciting that this digital employee basically working autonomously on the back end of an enterprise system. It's really amazing to see. The last example I wanted to kind of highlight on is the validation, because this is something not RPA was particularly good at in any way. So companies usually have a lot of documents, especially contracts. And if you want to do any automation with contract, it's a very tough thing to do, because contract is very unstructured data. The format is really different. And a lot of time, whenever companies make a new contract with other entity, you have to validate the contract based on certain policy. That's not something you can do with deterministic automation. But with agent, because it understands the semantic meaning of the contract and the even policy, it can compare those two different data, and if it pass the policy requirement or not, and if it doesn't have enough information based on the contract and the policy, it might do our web search to query certain word. Maybe they use specialized word that is not common language. So agent can research about it. Not only the internet, but the internal system can be leveraged using UiPath automation tools. And the agent can also have access to some context if the agent should be aware of certain domain taxonomy. So we can include those knowledge base in the context. So agent has agent can use that as another tool. And based on those sophisticated research, it can make the decision if it's good to go or bad. And even for each agent can output good or pass or fail for each contract lines if you want. So when you let the human to validate right after the agent validation, it's going to be much more easy to work with, because the agent already worked on the validation. So human just need to confirm if it was good or not. And the agent can even generate the reasoning of why agent made such a decision in natural language. So human can take a look at the description and the review based on that. It's really like human.
That's a good point. Yeah, that human in the loop validation could be extremely critical for some things, especially very sensitive documents.
Yeah, exactly.
Like contract.
And the important point is, although we still rely on human just to make sure the final output is going to be something the company can take a responsible on, but it doesn't mean using agent won't bring any value. Like imagine that you have subordinate that can work with pre-processing of each task, and you just need to confirm. That's reduce the amount of whole work a lot. I wish I had such an agent a while ago, but now it's a reality. It's quite amazing.
So that's 6 of the patterns that we've seen so far. Let's go and look at the patterns inside of this category or broader category of natural language processing. So there's really 4 patterns we're seeing: communication, summarization, sentiment detection, and translation. Can you give us a flyover, Masaki, of these 4 categories before we go to the next ones?
Yeah, for sure. So this is something a lot of people are already aware with the technology of large language model. Everybody knows large language model is really good at chatting, making communication out of it. Summarization, a lot of people are using large language model to summarize data, and the sentiment detection agent is also good at it, and even translation of some text in English to Japanese or something like that. I often use that. So in automations, sometimes it uses those common patterns as a point solution. But I think this is something people are familiar with already. It doesn't really require to think, come up with those automation ideas because it's so kind of obvious ones, I would say.
In the company I used to work for, I mentioned earlier, where we were using natural language processing technology to analyze peer-to-peer conversation that we got from the internet. One of the challenges was around sentiment, right? Because so many words in the English language can mean different things, right? So if you said something like, that car is bad, well, that could be good or it could be bad, right? Or if you said something like, that thing is fire, you might mean that thing is really cool or really neat or awesome, or you might mean in the context of an automobile, that thing is actually on fire, right? And those are 2 vastly different meanings with 2 vastly different sentiment scores.
Yeah, absolutely. Yeah, I think this is really fascinating to see agent can do those human-like tasks. There's communication summarization, sentiment detection. These are something for a long time human thought only human can do, but now agents can do such a thing. It's amazing to see.
Before we move off of this one, Masaki, given you speak Japanese fluently, is there anything to say about the translation aspects? This one pattern we've noticed. Is there anything you'd say about that one specifically?
Yeah, so I often use large language model solution to translate, because there's a nuance that I sometimes don't understand when it's written English as a non-native speaker. So it's quite amazing to see how large language model can capture some of the detail nuance and translate into the different language, incorporating with those nuance. And that can be utilized in especially for like a marketing aspect of the automation.
It's a good point.
Because if you are in global companies, you are operating things in different region of the world, and you want to make sure you will send the same message, but still incorporating with the culture of each region. And if you are operating global wide, you probably have to translate, I don't know, 5 or 10 or 15, I don't know how many languages. And if you can automate those process, it's going to save tons of time for marketing teams to do translation around their whole marketing materials. And the opportunity is huge.
That's such a good point. Such a good point. All right, well, let's wrap it up with looking at the last category and the two final patterns we see. So this is an area of reasoning. So this is all about drawing conclusions or predictions, using kind of existing information, and really the simulation of logical thinking and problem solving. So we've got two here, the final two is analysis and suggestion. Can you give us an overview of these two, Masaki?
Yeah, for sure. So reasoning is something, as Bill mentioned, only for a long time only human could do, like making a logical decision on some problem or some situation, and they make a analysis on top of it. For example, taking a look at CRM, some customer database or financial statement, slow it into the agent and ask the agent, hey, analyze this customer and what kind of opportunity we would have as a SIMS person. And the agent can really follow the guidance around what kind of analysis it should make, and the output this nice report basically of the customer. And the suggestion even goes more further, not only the analyzing the data, but it even creates a suggestion or like what to do next. Like it decides the next action. And the what's cool about suggestion is if it's something that the automation team already worked on for automating things, agent can call the automation process based on the suggestion that the prior agent made.
That's great.
So we started to see more and more opportunity in sales organization. Particularly, we are working on one big global enterprise company on sales support agent. Basically, they want some solution that as an input agent get natural language from salespeople. Hey, I want to know the sales information around this district on specific product. It's very natural language, very big natural language query, but the agent will convert it into certain query against multiple systems. That's where searching agent will work, and bring those information into the suggestion or analysis agent, make a quite an intelligent analysis or suggestion, and based on the output of the agent, human will take action or robotic process automation will take action on the enterprise system, or maybe another agent will take care of all the later part of the agent. So that's really
and you're talking about multiple agents, and I think this is probably a good time to summarize what we're talking about, because we're talking about analysis and suggestion in this reasoning category. Previously, we talked about communication, summarization, sentiment, translation. Before that, we talked about classification and extraction and formatting and so forth. Really, these 12 kind of what you call patterns. And I think the way to help the listener think about this is these agents are specialists or delineated based upon a skill set. Right? Whether that be classification or formatting or matching. And then these agents work together in concert so that they're specialists in their area, and not one agent is having to do all of these things and be an expert in so many different skills.
Yeah, you nailed it, the explanation. Yeah, it's absolutely like that. You should narrow the scope of the agent down into this small level, like those 12 different patterns. Sometimes one agent can include multiple types. That's totally fine if the output is consistent and accurate. But oftentimes, what we recommend customer to do is try to break the process down into this level, like classification, extraction, and divide the role in and agent role into those types. So that will make the output of the agent more accurate, consistent, and also it's easier to test the output because now you know what kind of a output is expected. If you combine all the solution, all the different types into one agent, you don't know the cause of issue of the agent really. It's really hard to identify what was the issue of the inaccurate output, because it could be the issue within the classification part, or it could be extraction, it could be suggestion. It really takes time to do so. So there are many benefits of separating the duty into small scope of agents.
When you were talking about analysis and suggestion, I was thinking about two use cases. One is personal and one is from a customer. So on the personal side, I think I may have mentioned this in a previous episode, but I got my homeowner's insurance policy and it was coming up for renewal, and I wasn't sure if I had the right coverage. I wasn't sure if my pricing was reasonable relative to other people in my neighborhood. So I thought about texting my policy to my friends who live in my neighborhood and asking them their thoughts. But before I did that, I took a picture of it and I uploaded it to an LLM, and I asked it, I said, "You're a home insurance expert. Tell me if I have the right coverage." And I gave it information about my home, the value, all that stuff. And I asked it to analyze my home insurance policy, again, just based upon a picture, and give me a suggestion on whether or not I should adjust my coverage, maybe whether or not I should change providers given the pricing. And it was extremely helpful and quick, obviously, in giving me nuanced insight into my policy, my coverage, and my pricing. I was blown away.
Yeah, and
that's
and I will add up some context here. So that was a personal example, but that's such a great use case that I think can be applied for enterprise context very well. And even if it's enterprise context, you probably want the agent to further research about other insurance companies, or maybe internally enterprise company have information around the insurance, like further information, like who is involved in contract, what was the previous contract. Those information are usually stored in a secure environment that not necessarily it's easy to get. It takes time to manually extract those information. But if you have robotic process automation ready to gain those information, now agent has access to those data, and it will autonomously bring those information and make a more sophisticated decision making based on the data that agent has access to through RPA. So the accuracy is going to be really good.
Yeah, because you have this non-deterministic LLM-powered agent, right, that does reasoning and thinking and problem solving, paired with a deterministic or rules-based robot, traditional RPA, and they work in concert. Really, it's really 1 + 1 = 3, right? Let me give you the customer example, and then I'll ask you to summarize our episode before we sign off here. The customer example, again, I'm going to go back to analysis and suggestion, is the customer has customers that call to the call center, and they have different policies and procedures that may or may not apply to them, right, based upon their unique circumstances. And the customer service agent, the human answering the phone, has access to these policies and procedures, and maybe 10, 20, 30 or more. And they have to, based upon their own information, their own knowledge, their own training, have to decide which policies and procedures are relevant for that specific customer they're talking to. And the turnover in a call center is pretty high, right? So, and the training of these customer service agents on all of these policies and procedures takes a lot of time. And that call with the actual customer can go on and on and on for many minutes. So that's where an LLM-powered agent in an agentic automation workflow, doing the analysis and making the suggestion to the human agent, who can then resolve the customer's issue quickly and accurately, is so valuable and something that call centers haven't had access to until now.
Yeah, that it's very exciting. And in terms of the action, as I described, the action after the analysis or suggestion of input, the next action can be passed to another agent. That could be one of the pattern which sit in data operation, like a validation of contract, or classifying certain data to make the further automation more sophisticated, searching more information from other systems based on the result of the suggestion. So that's why it's important to componentize those agents, because now as you create more agent that follows those smaller scope agent, now those will be a building blocks of future automation opportunities, and the scalability is very significant.
Great point. Well, Masaki, as always, it's been great talking to you about these things. Hopefully this was insightful to our audience. I think these patterns that we're seeing develop, these 12 that we highlighted today, should give our listeners a very good framework for how to build and manage their own agentic automation workflows. So as we sign off, I will just ask our audience, please like and subscribe and comment. We'd love to hear what you think about this episode, questions you have, feedback. Masaki, any parting words for our audience?
Let's automate everything with agents.
I love it. Thank you, Masaki, and we'll see you all next time.